Anyone who has worked with standard Unity assets before will immediately recognize these sounds. Changing the default sounds can instantly improve our game's appeal, but we can do even better than that. G'day everyone, in this video we're going to set up a system to detect what surface the player is walking on and change the footsteps to match. I'm using the first person controller that comes with the standard assets, as it already has the logic in place to call random footstep sounds incrementally. In this project I have sound effects for 5 different surfaces, and for each surface there are 4 footstep sounds and a jump and a landing sound. So with our standard assets imported, let's head to where our first person controller prefab is stored, and we'll drag one into the scene. Over in the inspector under footstep sounds, we'll click on the little arrow here and expand that to see that we only have 2 footstep sounds in here, and they don't sound that great. This is where we're going to load in our own footstep sounds. So before we start, we'll have to take our first person controller script, drag it out of the standard assets folder and put it into our own scripts folder. And this is because all of the scripts that sit within the standard assets folder will be compiled before the scripts from most other folders. So we won't be able to reference any custom classes from a script that sits inside our standard assets folder. So let's open up our first person controller script. And we'll start by adding using system.collections.generic at the top here. And that'll give us access to change this audio clip array into a list of audio clips. Right here, we'll set this to be a new list of audio clip. And this is because we want to dynamically add and remove audio clips into this variable here, which can't be done with an array. So because we've changed this to a list, it'll also bring up an error down here where we need to change length to count. Save that, head back into Unity, and we'll have a look at the terrain. If we navigate over to the Paint Textures tab, you can see that we've got 4 different terrain layers here, each with a very simple and descriptive name: grass, rock, mud, gravel. And these names are what we're going to be checking for in our code. So let's create a new script. We'll call it terrain checker. And this script will contain all of the logic we need to figure out which layer of the terrain our player is standing on. So we can get rid of start and update, and we also don't need to derive from mono behavior. The first function we need will be private, and it will return an array of floats. We'll call this getTextureMix. And for the parameters, we'll pass in a vector3, which will be the player pos, and a terrain, which we'll call t. Now we want to store a few of the components attached to our terrain here. So we want to store its position. We'll type in vector3 tpos is equal to t.transform.position, and the terrain data, which we'll call tdata, and this will be equal to t.terrainData. So we also want to store our player's X and Z positions relative to where they are on the terrain. And this line can be a bit confusing, so we'll start with the X axis. We'll create a new int, call it mapX. This will be equal to playerpos.x minus tpos.x. So the player position minus the terrain position. We'll wrap this in brackets. Divide that by tdata.size.x. And then multiply the whole thing by tdata.alphaMapWidth. Now this will come up as an error because we're trying to put a float value into an integer. So we'll just round this off to an int. mathf.round to int. And there we have it. We have our player's X position relative to where they're standing on the terrain. So to get the Z position, we can just duplicate this and change all of the X's for Z's. And we want to change alpha map width to alpha map height. Then from these 2 values, we're going to create a 3D array of floats, and we'll call this splat map data. This will be equal to tdata dot get alpha maps. So if we look at the description for get alpha maps, it returns a 3D array of floats where the third dimension represents the mixing weight of each splat map at each XY coordinate. And while that is an accurate description of what it does, it's not exactly user-friendly. I have an example to show you what that line does. So I head back into Unity, disable my first-person controller, and enable the example game object here. So I'll hit play, and I can drag around this cross here, and it will tell me all of the different texture weights at that point. So if I drag it in the middle here, we've got a combination of all of the different texture weights. Over here, we can see that the gravel is the only texture at this point. Grass is the only texture at this point. Rock and mud. And these are the values that will be going into the third column of our splat map data array. So we'll stop that and head back into Visual Studio. What we want to pass in here is map X, map Z, and we want a width and a height of 1. Now again, what this is going to be doing is populating the third column of our array with all of the different texture weights at these 2 points with a width and height of 1. So let's create a new array to store all of those values. It'll be a float array. We'll call it cell mix. And we'll set this to be a new float array, the size of which will be splatmapdata.getUpperBounds. And in here we'll pass in 2 and then we'll plus 1 to that. Now we just need to extract all of the values into cell mix. So we want a for loop, and this will go until cellmix.length. And all we want to do in here is set cellmix at the position of I to equal splatmapdata. And we don't care about the first 2 columns. All we care about is the third one, so we'll put in I there. Now outside of the for loop, we can just return cellmix. Next up, we want to create a new public function, which will return a string, and we'll call this getLayerName. This will take in the same parameters as getTextureMix, vector3, player pos, and a terrain, which we'll call T. And in here, we want to store the result of getTextureMix. So float, and we'll call this cellMix. And this will be equal to getTextureMix. And we'll pass in the player pos and T. Now we want to create a float value for the strongest texture. We'll call that strongest. We'll set this to 0. And we want to create an int for the index of the strongest texture. So we'll call this max index. And this will also be set to 0. Now we can loop over all of our values and find the strongest texture. So we'll loop until cellmix.length. And in here we want to check if cellmix I is greater than strongest. Then we want to set the max index to equal I. And the strongest to equal cellmix at the position of I. Now outside the loop here, we can just return t.terrainData.terrainLayers at the position of max index dot name. Save that. We'll head back into Unity and we'll create a new script and we'll call this footstep swapper. In here, we'll want a reference to the terrain checker. So private terrain checker. And we'll call this checker. And we also want a reference to the first person controller. So at the top of the script here, we want to make sure that we're using Unity standard assets.characters.firstperson. Now underneath the terrain checker, we'll make a private first person controller, call it FPC. And we also want a private string for the current layer that we are standing on. In start, we'll assign our references. So checker is equal to new terrain checker. And FPC is equal to get component first person controller. And this is the script that we're going to stick on the first person controller. And we'll have all of the logic inside it to raycast down and check if we actually need to swap our footstep sounds. So we'll save that, create a new C# script, and And we'll call this footstep collection. And this class is actually going to be a scriptable object. We can get rid of start and update. And at the top here, we want to type in create asset menu. File name is equal to new footstep collection. And menu name is equal to create new footstep collection. So in the class, we want to create a new public list of audio clips. We'll call this footstep sounds. We also want a public audio clip for the jump sound and a public audio clip for the land sound. Save that. We'll head back into Unity. And in my assets folder, I'm going to create a new folder called footstep collections. If I right click here and go create, you can see that we've got a new menu option for create new footstep collection. This is an instance of the class that we just wrote. So we'll call it grass. We'll lock the inspector, head over to where our grass audio clips are, and we can drag in all of our footstep clips into the list, our jump sound, and our landing sound. Now let's create 3 more for each of the other terrain layers. Now with all of those collections created, we can head back into our footstep swapper script and create an array of footstep collections. We'll call this terrain footstep collections. So we can get rid of update. We can create a new public void function called check layers. And with this function, we're going to raycast down from the center of the player. We're going to check to see if there is a terrain underneath us. Check if the layer we're standing on matches our current layer. And if it does, then we can swap the footsteps. So first off, we'll create a raycast kit. And then we can do our raycast. So if physics.raycast, we'll pass in the transform.position, and we want to raycast down. So vector3.down. Then we'll store the hit information at a distance of 3. Now we want to check if the terrain exists. So if hit.transform.getComponent terrain is not equal to null. Then we want to check if the layer we're standing on matches our current layer. So before that, we'll store our terrain. We'll call it t is equal to hit.transform.getComponent terrain. And now if our current layer is not equal to checker.getLayerName, we'll pass in our transform.position and pass in t. So if they don't match, then we have stepped on a new layer, and we can set our current layer to equal checker.getLayerName. Transform.position t. Alright, so now we have the layer name stored in current layer. Now we want to do a for each loop over all of our footstep collections. We'll call this collection in terrain footstep collections. And we'll check to see if the current layer is equal to collection.name. And that is the name of the actual asset file of our footstep collection. And in here, we haven't created the function yet, but we're going to tell the first person controller to swap footsteps. And we're going to pass in the collection. So we'll head over to the first person controller script, create a new function called swap footsteps. And this is going to take a footstep collection And in here, we're just going to clear out the m_footsteps list. Then we're going to loop over everything in the collection.footstep sounds. And we're going to add it back into m_footsteps. Outside of the loop, we'll set the m_jump sound to equal collection.jump sound, and m_land sound to equal collection.land sound. Now we want to head up to the top of the script and add in a reference for the footstep swapper. We'll call this swapper. And because this exists on the same game object, we can just set this to get component, footstep swapper. And there are 3 places that we need to check to see if the footstep sounds need to be changed. So at the start of play footsteps audio, we can type in swapper.checklayers. We can copy that. We also want to check at the start of play jump sound. And we also want to check at the start of play landing sound. And here's a little tip in play landing sound. If we change this to play one shot and pass in m_land sound, it sounds a lot better. Now that was a lot of work, so let's save our scripts and we'll head back into Unity. We'll enable our first person controller, disable the main camera and the example game object, and we'll add in our footstep swapper to the first person controller. I'll have to drag the first person controller up a little bit. I just realized I'm not getting anything over here in the corner because I need to make the footstep collections public. Okay, so let's go ahead and lock the inspector and drag all of our collections onto the list over here. And if we hit play, we'll walk over to the gravel area. We can see that the jump sound has changed to gravel jump, gravel land, and we've got all the footsteps in there. We'll head over to the mud, head over to the rock, and head over to the grass. You can see that if we jump off one surface type and land on another, it will update it on the landing. Now this will work for terrains, but what if we're standing on a mesh that we've imported and has a different surface type to anything on our terrain? So I've got a game object here, which is just a cube with a wooden texture. We'll turn that on, we'll drag up our first person controller. And this functionality is actually really easy to add. There are a few different ways we can do it. We could just tag the object as wood and check that against the name of our collection. However, that might not work in all situations, like if the collider extends the bounds of the mesh, or if we want to use the tag in another way. So instead, I'm going to head back into the scripts folder, create a new C# script, call this surface type, and we'll drag that onto our wood game object here. We'll open it up in Visual Studio. We'll get rid of start and update, and all we really want in this is a public footstep collection. And we'll call this footstep collection. Save that, head back into Unity, and we'll create a new collection for the wood footsteps. Lock the inspector and drag in all of our audio clips. Alright, now we can just drag this onto our wood game object. Head back into our footstep swapper script, and just after we're checking for the terrain, we can check if the hit.transform.getComponent surface type is not equal to null. We want to store our footstep collection is equal to hit.transform.getComponent surface type footstep collection. We want to set our current layer to equal collection.name, and we want to tell our first person controller swap footsteps, pass in the collection. And that's it. That's all we need to do to create a dynamic footstep system that is easily scalable and will work with any type of surface in your game. Thank you very much for watching. I hope you enjoyed the video. If you did, please like and subscribe. Leave any thoughts and suggestions down in the comment section below. Thanks for watching.